Hi, my poster is on using uniformly labeled C13 glutamine as a tracer for liver metabolism. Now, why is this important? Well, some liver disorders and diseases have strong metabolic components associated with them. We can use isotopic tracers to look at metabolic alterations and activities. In this experiment, we test glutamine's effectiveness as a tracer for liver metabolism and compare this to propionate, which has been a proven tracer for liver metabolism, but because of its low concentration in the blood, its effectiveness has been questioned. This is not a problem seen with glutamine. In this experiment, we took a mouse and fasted it overnight. The next day, it was anesthetized and an incision was made in the midline. The liver was then cannulated, or a thin tube was inserted into the portal vein. The liver was then taken out of the body and attached to a column. Perfusate was run through the column, with the perfusate being made of the Krebs buffer, mixed fatty acids, pyruvate and lactate, as well as our uniformly labeled C13 glutamine. We then took the efferent perfusate, or the perfusate coming out of the liver, and extracted glucose out of it using a perchloric acid extraction. We convert glucose to monoacetone glucose and purify the monoacetone glucose in a column. We are then able to run our HNMR on the monoacetone glucose and get a clean signal. As you can see in figure 2, glutamine is just as effective as a tracer for liver metabolism as propionate. And it's important to note the glucose that we collected can originate from different places, such as gluconeogenesis or glycogenolysis. We can use the 3 equations listed in the poster to calculate where the glucose came from. In this experiment, around 18 to 75% of the glucose came from glycogenolysis, which would indicate that there was incomplete fasting, and then there was about 18 to 62% from the Krebs cycle. Overall, the main point to get out of all this is that glutamine is just as an effective tracer as propionate, except it has much more concentration in the blood than propionate, which would make it a more effective tracer.